Hello, everyone. So far, we have seen how we can use models as well as model abstractions in LabVIEW. In this video, we're going to look at the next step, which is how we can use model with your data or your domain knowledge to get the best out of the models. For this, let me open LabVIEW and demonstrate it with an application. So I have a LabVIEW application here, which is similar to the one that you have seen in the previous video. I have a simple creating an instance of an OpenAI 4.0 mini, um, doing an inference, a text to text response, and then destroying it. Now let's take an example. I have an application, and whenever my application has an issue, I throw custom errors. And I wanted large language models to look at the errors that I have coming out of my software, and it should provide a possible root cause analysis for that, right? So let me actually copy paste my custom error into the system as an input message, and in the system message, I'll explain the root cause for the given error. So when I run the system, LLM is going to look at the system message to understand what it has to do, what is the boundary in which it has to work, and it'll look at the input message, the error, and then it provides me a response for it. And the response is what it believes as a potential root cause for this error. So it kind of came up with it could be a mechanical failure, it could be electrical issues, clogged filters, and whatnot. It's a pure hallucination, right? Because the LLM doesn't know anything about my system. It just generated the response purely based on its data that it has been trained from the online. Um, and again, it's the hallucination is nothing but what LLM believes is a right answer, but in our context, it doesn't really make sense, right? So, how can we make the response better? Is by providing much more context to the LLM that it has to work with. So, I have a notepad full of um, different error that my software can produce, as well as a potential root cause or the possible reasons why this error could have happened, and the how to fix. Right. So what I'm going to do is I'm going to copy this few errors, maybe three errors, and its uh, root cause as well as how to fix situation into the system message. So I just copy pasted that into the system message, and what I'm going to say is this is the context, I'm just going to say this is the domain context. And in the system message, I want to add an extra constraint telling, explain the root cause for this given error only if you see in the context. If not, say I don't know. What I'm essentially trying to do is I'm grounding the model to work within the context or the domain knowledge that I kind of provided. And if it doesn't find anything relevant, I wanted it to kind of say it doesn't know. So now when I run the system, what it does is it kind of reviews the context as well as the input message and comes up with a root cause. Here, like the error that I got is 8903 3 failed. And if you look at it in the context, I have error code 8903 and it says the potential is because internal motor fault communication, and it kind of provided that as a root cause. Now, if I say the error that I have is 8905 and I run it, it comes back with I don't know. The reason is there is no uh, context provided for this error 8905, right? So this is the way we provide. This is something called context engineering or prompt engineering, where essentially we are providing much more domain context or relevant context into your input texts, so the model can be tuned to work for this for your data, right? um, let's take the next example, right? You can ask me a question where, like, okay, this is great. You fed in like three potential error informations, so that it kind of picked from it. In the real world, I have thousands or 2000s potential um, different types of errors. Can I provide everything into this particular system message? Now, that is before I'm answering the question, right? I want to kind of talk to you about a term called context width or context size, right? Each LLM has a context. I mean, they call it context width, context window, or whatnot. Essentially, it's more about how much words or tokens and large language model can take as an input to provide a response. There is a max threshold for each of it. 2 years back, LLMs that are released had like 4,000 tokens, 8,000 tokens as a context window. Today, the context window of the LLMs has been really, really large. Some LLMs can actually take around like a lakh or 100K, more than 100K as a context window. Now, the reason for increasing the context window in the new models is because, like I said in this example or examples like this, people can actually provide more of their domain knowledge into the context, and they can actually make the LLM work appropriately. Right? But still, there is a limitation. Doesn't what do I mean by that is LLM still has a context window threshold. Beyond it, it's not going to work. And we can't guarantee that we can actually provide all your domain knowledge within an LLM context. This is where concepts like retrieval augmented generation comes in. What I have just showed you is more like an augmented generation. I'm just augmenting my domain knowledge and generating it. Because of the limitations of the context window, we need to kind of look at technologies or techniques like retrieval augmented generation. This is something that I want to cover in the next video. But for now, I want to kind of close this particular video by providing you what we looked, which is we looked at context engineering, how we can actually provide domain knowledge in the context engineering to get LLM do what we wanted.